Okay. Just a quick reminder, this session is going to be recorded and it's going to be uploaded on YouTube. So if you share your screen, uh, this is going to go on YouTube. We might not be able to blur it. Okay, so with this being said, let's quickly get started with AI 900. I know I've said this before, but I want to say it once again for the people who are watching this on the record. Uh, we are going to have two sessions for this, which will be divided into two parts each. So today is Saturday. We'll have a morning part and an afternoon part. And Sunday, we'll have a morning part and an afternoon part. By attending these four sessions, you would be at a spot, ready to give the AI 900 certification. One question that I've been receiving about dumps. So we did discuss about some sample questions last time. I did give you some sample questions last time for AZ 900. Similarly, for AI 900, we do have practicals planned. We do have, it's not just a theoretical course, okay? Since this is one of the easiest certifications, we do have scope, we do have the time to cover a couple of practicals. So tomorrow specifically, we will be covering some custom machine learning, computer vision practicals, where we'll have our own data set, where we'll be training our own machine learning model, and then we'll be deploying it. So that could be one of the minor projects which any one of you can follow along with me if you want. And again, that's optional. It'll take at least about 45 minutes. That's what I'm anticipating, considering I'll have to answer quite a few questions as we progress. But ultimately, it's going to be a really great experience for many of you who are trying, your artificial intelligence services for the first time, or Azure services to be specific for the first time. Now, just as a disclaimer, so that all of you know, the certification does not require you to know the practicals, but it is always a good thing to have a little bit of hands-on, or at least watch me do the practicals so that you can understand what is being covered. As I've said it quite a few times, this is one of the easiest certifications. I hope all of you understand each and every bit of it. I hope everyone is able to connect. And if anyone has any questions at any time, feel free to ask your questions in the chat, raise your hand. I'll be more than happy to answer your questions, queries, and doubts. Okay. So the first question that crosses our mind when we talk about what is artificial intelligence, because we've been talking, we know that the certification is about AI 900, it's about artificial intelligence, Azure artificial intelligence, and 900 says that it is a fundamental certification. So the first thing that Azure expects you to know, that what is artificial intelligence. So if you can look at the definition over here, it says AI is the creation of software that imitates human behavior. Now, you guys might have seen it. It's getting really popular these days. If you follow, reels on Instagram, or a lot of shorts on YouTube, or just the social media in general, you'll see a lot of discussion and a lot of disruption is going on with the introduction of artificial intelligence models that are being popularly used. A very common one of them is ChatGPT. I'm quite sure you might have seen it somewhere, you might have heard of it, you might have used it. If not, we will be talking more about it in this series. The reason being, Azure is very dynamic with the content for the certification exam. So a few months back from today, we were not required to know about OpenAI, but this is the latest revision of the exam, and the slides have been updated just this week itself, so that we have the latest content. And one of the major parts of the certification is also to talk about and learn about open artificial intelligence. Open AI is going to be a topic of discussion as well. We'll be talking about the details. We'll be talking about how it works, what are the capabilities, what makes it secure, and the governance around it, and how is it related to Azure. Now, many of you might know this, might not know this, but ChatGPT is one of the tools that is now, it working in accordance with Microsoft. So OpenAI is working with Microsoft, and for that reason, Azure has many OpenAI capabilities as well. They're not very much open to the public, so there's not a lot of discussion around it. But since you'll be preparing for the certification, we'll be covering that aspect as well. Now, coming back to what is artificial intelligence. So artificial intelligence is the creation of software that imitates human behaviors. So for example, if we are talking to a human, let's say if we are taking advice, or if we have a question that we want the question to be answered. So if a computer is able to answer a question based upon certain rules, based upon certain learnings, based upon the data that we have trained it with, that is covered under artificial intelligence. It's not just limited to the behavior, but it also includes the capabilities, and it can be used to improve healthcare, enable physical abilities, create smart infrastructure, entertainment experiences, and help save the planet. Now, this is something which comes straight away from the documentation. So this is honestly, I'll say this is arguable, because some of you might say that AI might be taking away jobs, which I kind of agree to. And then some of us might say that AI is making a lot of redundant tasks easier for us. And I totally agree to that as well. So this depends upon, person to person, how someone interprets this, how someone thinks about this. But in general, uh, AI can be used in multiple applications. One of the most common ones, as I talked about, is ChatGPT, where people can go, they can put in the queries, and it's an open AI model. It is going to give you back a response which can help you with decision making. It can help you with suggestions. It can help you with, text writing. It can help you with a lot of other features. I'm not going to go into each one of them because there's a dedicated slide for, all the concepts. So a lot of stuff is going to come in the further slides. Um, in terms of key workloads of artificial intelligence, we will be looking at machine learning. Uh, we'll be looking at anomaly detection. We'll be looking at computer vision, NLP, and knowledge mining. To name a few, anomaly detection is something which is finding out something out of the ordinary. Now, let me give you an example. So let's say Soham, and I'm just going to pick names from what I see on my side of my screen from Zoom. So whoever name is there, I'm just going to pick it as an example. So let's say Soham goes into a bank and withdraws $100 every 3 days. Let's say that that's a pattern. And suddenly, one day we realize that Soham is withdrawing $3,000. So that is anomaly, right? Because that is out of the expected behavior. So we might want to call up Soham and we might want, hey, Soham, we want you to identify yourself. So please answer a couple of extra questions. Please, provide us some sort of, uh, a multi-factor authentication so that we can authenticate, yes, this is you. And we want to be sure that, you're not doing this under any pressure. You are who you claim, who you want to be, and do you have the authorization to do that? So anomaly is basically something out of the ordinary, and this feature of artificial intelligence is used in multiple applications. For example, fraud prevention. So when we talk about banking, when we talk about transactions, AI can detect fraud at a very good scale because you can train it with data. And if it feels that there is something which is out of the ordinary, it might present you with a challenge and someone will have to go through that extra challenge. But it does make sense because then, at the end of the day, you are securing your data. Moving on to computer vision is computer analyzing the real world images and videos for you. For example, if we look at a very good example of computer vision will be, let's say, Tesla, where you have a lot of sensors, you have a lot of cameras, and a vehicle is able to identify what is there in front of it, and then that gives it self-driving capabilities. And we're going to talk about each one of them later, so I'm just introducing them to you at this stage. Moving on is natural language processing. Now, computers initially, if we go back maybe a few decades from now, when we were just in the starting era of computers, when we were working with assembly language, maybe C++, those languages, computers were expecting us to give an input, a simple program. That's what I'm trying to say. They were expecting us to give an input, they used to do the processing and give us an output. Pretty straightforward stuff. But now, when we are having more human interaction with the computers, we are giving in the information as a human. For example, there might be 2 ways or 3 ways or indefinite number of ways to say the same thing. But the computer or the device needs to understand what you are saying. So whenever there's a human interaction in form of text, in form of words, in form of maybe, signs, you are looking at natural language. So natural language is the language in which humans communicate. Computers work on 0 and 1. So if I type in, if I'm using a calculator and I enter 5 plus 5, the computer knows, okay, the person is talking about 5 plus 5. That is the expected input, and the expected output will be the sum of 5 plus 5 is 10. But when we talk about natural language, it is how we communicate. As I said, there could be multiple ways of saying the same thing. So now our computers need to understand the context. They need to understand if someone is saying, what is 5 plus 5? So they need to understand, okay, the person is talking about 5 plus 5. Someone could say, what is the sum of 5 added to 5? Uh, what will be the result if 5 is added to 5? And contextually, we are referring to the same thing, but there are multiple ways of saying it. So when you have humans that interact with computers and humans use natural language, we will be exploring a field of artificial intelligence that is NLP. We'll be talking about this where humans will be connecting. So wherever you have human input, wherever you have a human entering in the chat, you're using a chat bot, you're using something like, let me mute the device first. If you're using something like Alexa, and then it talks to you. So if I say, like I can show you a real good example, a very quick one of how this works and how natural language processing works. So Alexa is a real good example of this. So Alexa, what is 5 plus 5?
5 plus 5 is 10.
Straightforward. Now let me use another statement. Alexa, what will be the result if 5 is added to 5?
From schoolforchampions.com. If you add 5 and 5, you get 10.
So you see, now depending upon multiple ways of saying the same thing, the context is that the user is asking for a simple addition of 5 plus 5. So when we look into AI, with time, we try to train it, we try to improve it. And whenever we are passing natural language, AI has a field of natural language processing where the computers try to understand. Uh, oh, great. So yeah, I know that's a very common thing. Whenever I'm watching a show and someone refers to Alexa, my Alexa gets activated. That's why I've started to keep it mute by default. But I hope you guys get the idea. So whenever some human is interacting with the service and we are passing in our language, or we are not giving a hard coded input, we are not following a format. For example, we are typing on ChatGPT or any other chatbot. That's where we are using in our natural language. Now, another terminology that you need to know for the certification is machine learning. So machine learning is a way of teaching computers to recognize patterns in data. So this is what it is all about. So when we talk about ML, in simple words, it is nothing out of the world. It is just having a lot of data, telling the system that, okay, if this is the data, this is going to happen. If this is the system, this is going to happen. So basically, when you train a machine learning model, you are telling the model, hey, this is a cat, hey, this is a cat, hey, this is a cat. And tomorrow you show it something, some image, it'll be like, okay, you have shown me 100 pictures of cat. From my learning, I feel this resembles a cat. Okay, so that's what machine learning is. In simple words, you are teaching computers to recognize the patterns in the data that you're inserting. Now, that data might be text, it might be structured, it might be unstructured, it might be images, it might be videos, it might be, models that you create. And when we do the practical, it's going to be really, really fun tomorrow. I've not kept anything practical for today because I want to cover some content, some significant content, probably 60-70% of it. And then depending upon the time we'll have multiple practicals tomorrow. So with AI, the capabilities are endless, and these can be, great projects to add on your profiles as well. So for that very reason, I want to keep the practical time tomorrow, because if we have time, I do not mind doing something extra on this. However, if you guys are interested, I could show you a mock, a very small demonstration in the break today, so that all of you can pay your attention and you can understand how things are working out. Okay, so now, when we talk about machine learning, we are training computers to recognize the patterns. The question is, why do we train the computers to recognize a pattern? What is machine learning going to do for us? The most common use of machine learning is making predictions. Making predictions like tomorrow, is it going to rain? Like let's talk about a very generic example of machine learning. For example, we have the weather forecast, right? So depending upon what the weather has been in the past, if it's been windy and the next day it's been rainy, if it's been, if the humidity is above certain percentage, it's going to rain, or if the visibility, if it's getting cold, the visibility might get low. These are the predictions that we make. So previously we were dependent upon a lot of calculations. And now when we have historical data, we put them in a machine learning model. The machine learning can do predictions for us that, okay, the probability of something, the weather going bad is so and so. The probability of it being sunny is so and so. The probability of a flight being delayed is so and so. The probability of, like calculating the probability, making decisions based upon the probability, having certain thresholds is all that you could be doing with machine learning. In addition to that, you can improve performance with time. That is something which always comes with ML. Now, let me tell you, I am one of the early adopters of Alexa. I've been using this since 2018, I believe. That's been quite some time. So initially, when I started using the technology, it was not able to recognize a lot of accents. It was not able to recognize what I was trying to say. Though it had far field recognition. I could be standing at the corner of my room and talking to Alexa, but the communication might not have been the same what it is today. So that is something about machine learning. It improves over time. So Alexa was only when I started using it, it was only available in English. Eventually, they launched because I was using this in India, so they launched the default languages English India, which could understand the Indian accent a little bit, and then they launched it in a regional language called as Hindi, and then Alexa became bilingual, so you could talk to it in English or you could talk to it in a regional language, and it's going to give you a response in that language. So that is the thing about machine learning. It improves with time. So the more data you feed into a model, the more mature it gets, right? So let's say if I show you 50 images of cars and then I ask you to recognize a car, you'll be able to do that. But if I show you 500, you will be having a higher level or higher degree of confidence. And then when that becomes 5,000, it becomes more. With every time I'm adding more and more data, the capability of that machine learning model are increasing with time. So for example, if let's say I feed my machine learning model with the stock data, the stock market data. If I only feed the data for the past 5 days, obviously it's not very mature. The if the stock market is up, my model will be trained to believe that up is the only thing. But if it feed it with data of the past, let's say 15 years, 20 years, it'll be able to perform analysis. It'll be able to make decisions like, okay, this is what happened and this is what might happen. And this is where good and bad models come into play. Machine learning is not always good. It might fail as well. So obviously it is not, just the way like people write code, people might write good code, people might write bad code. Similarly, machine learning models might be good. They might not be so efficient. They might be bad, depending upon, how they have been created. So there's a very high possibility that machine learning predicts something which is outrageous, which is not right, which is absolutely wrong. And at the same time, it is also possible that we get highly accurate results. Now, what I can say in general about machine learning is the more data you feed into it, the more time that it has been around, the more time you give it, feedback like, yes, if it's doing the right thing, or if you program it to understand that, okay, if there's a spike, and if you have this spike, and if something is increasing at a rate of, let's say, 40%, then it is highly volatile, so it might understand that. But if I've already trained a machine learning model with the data where the graph is going up, it will never be able to recognize what happens when something crashes. So that's why it's very, very important for you to, when you're using machine learning, to train a lot of data and understand the fact that the performance comes with time. So a lot of slides on this later on, because again, we are going to the entire certification, as I said, is about AI and ML, and then we'll be talking about a few details of the services that Azure uses. But for most part of it, for at least for the beginning, it's going to be generic about artificial intelligence and machine learning. So machine learning algorithms can be used to solve a wide variety of problems, including image, speech recognition, natural language processing, fraud detection, predictive maintenance, among many others. So as I talked about anomaly detection, that is fraud detection. So anomaly is something which is out of the ordinary. For example, if you have, let's say if you are a bank looking at the number of transactions that you make, the size of transactions, if it is something out of the usual, the bank might, get triggered and they might have some additional ways to authenticate you. Now, one thing, when I moved to Canada, I realized that there, banking is not the same as many other parts of the world. For example, I come from India, and if I had to do a transaction for less than $1 as well online, I could not authenticate myself automatically. I used to get something called as a one-time password on my mobile phone. So let's say I enter my credit or debit card details, and then the bank will send me a one-time password, and I need to enter that OTP to complete the transaction. So, it's like that's how it used to work, and that's how it used to be normal for me. But when I came to Canada, like about three and a half years ago, one thing that I realized was that things are very, very different. So when I make a transaction, I'm not prompted to enter a one-time password, because apparently the security is better, the fraud rate is less. And I'm not going into the specifics of the banking industry, but that is one thing which is different. But the moment I try to make a transaction above a certain amount, for example, I was trying to book flight tickets, which costed, I think, over $2,000. The moment I tried to make the transaction, my bank did not allow it to go through. And again, this might vary from bank to bank, this might vary from case to case. But for my bank, the usual transaction size that I have is not close to $2,000. On an average, I might be eating out, maybe 15, 20 bucks. I might be doing some groceries, maybe 40, 50, $60. I might be going out to the movies, $20, something around that. So the average transaction that I'm doing is, 20, 30, 40. At max, let's say if I go to Costco, the max I might spend is like $400, $500, right? And that too is on a debit card. And there too, I'm, validating with my PIN. So obviously there is some additional validation that is done. But for online transactions, the amount is usually not high. But let's say the moment I try to make a transaction for above a certain amount, the bank is getting triggered. The bank is like, okay, I'm not saying this is fraud, but this is anomaly. This is not something, that the person is doing usually. So let me prompt a one-time password so that you'll get a message on your phone. You need to enter the password. That is, multi-factor authentication. So first factor was I entered my card details, which obviously I have. And then at the same time, I need to enter my one-time password to prove that, okay, this is who I am and this is who's trying to make the transaction. Something similar happened with me last year when I was traveling, when I was in the US, and I was trying to make a transaction on a Canadian website. The transaction amount was only, I think it was under $50, but I was still prompted an OTP because of my location. So basically, machine learning considers a lot of factors like your location, your IP address, your and this you could train it to. Okay, I'm just giving you an example. Like if you talk about fraud detection, you are looking at you're looking at the amount of transactions, you are looking at the IP address, you are looking at the time of the transaction, you're looking at the frequency of the transaction. So multiple things are going into play. It's not just very simple, like if it is above $500 rate, raise a concern. What if the person does not have their phone? So you want to balance things out, right? And that's why machine learning is used. You could have hard coded it like, okay, if transaction is above 500, ask OTP. But what if the person is doing, transactions on a daily basis? When the needs are customized, for example, let's say Jatin might be spending an average transaction of 500, but I might be spending an average transaction of 100, and Ruchika might be spending an average transaction of 300. Let's say different people are having different transaction size. So the fraud detection needs to kick in at a different threshold for different people. And since that's going to be different for different people, that's when we are using machine learning, because we do not want to generalize, we do not want to hard code, we want our systems to improve. Uh, let's say if I am yearly booking a ticket for $500 again and again, again and again, let's say at Christmas. for X and Y event. With time, machine learning, if it's an advanced model, if it's a good model, it will be able to understand, hey, this does not look like anomaly, because now I have the data for the past 5 years and this person has been, doing the same thing again and again. And then you can have a good model which is only asking you questions when it feels something is absolutely going wrong. Does that make sense to all of you? So simple tasks could be done without machine learning as well. But the reason we use machine learning is to have a more optimized experience, a more secure experience. And, we just want it to be as accurate as possible, which is something which comes with time. Any questions still here, anyone? Or if it's all good, give me a thumbs up. Just want all of you to be interactive. Okay. Now, Now coming to machine learning in Azure. So Microsoft Azure provides the Azure Machine Learning Service, a cloud-based platform for creating, managing, and publishing machine learning models. Now, what we were talking about till now was AI and machine learning in general. Now, when we talk about cloud, a lot of machine learning workloads are run in cloud. Now, as we know, cloud is not your machine, it is someone else's computer. The basic definition I give for cloud, it is evolving with time, right? Because today we are sharing knowledge. For example, we are sharing data, we are having much advanced trained models. Now, Meena might be doing a lot of research at their home system, but if they do not share it out with the world, the knowledge is only limited to that system. But let's say Urvish wants to do something on the cloud. If you're consuming the cloud service, with time, the service is improving because you're feeding it more and more data. So the more data that you feed to cloud, the more optimized, the better solution, the probability of having a better solution comes from the cloud. Now, because we are doing it in Azure, it makes our life easy because we do not need to go through the hassle of configuring everything from the scratch. A lot of workloads for machine learning and artificial intelligence are provided by the cloud itself. We could be choosing a model. And even if we want to use our own model, let's say we have a use case where we want our personal data, we can by all means do that on Azure, and we can be having custom trained models without having the need to learn the artificial intelligence background, without having the need to learn the mathematics behind it. Now, when we talk about AI, ML, neural networks, technically we are talking about the maths, right? We were talking about what are the characteristics, how do you get the characteristics, you do the calculation on those characteristics, right? Now, when you're using Azure, your life becomes easy because it is not required. And I'm using the word required because you might or you might not want to use that code, right? You might want to write your own code. Let's say if you've done your research in artificial intelligence for 10 years, 5 years, 3 years, you do not want to use someone else's model. By all means, you can do that on Azure. Let's say if you are a beginner who has who just wants to get started and does not have any data, just wants to get the look and feel of it, by all means you can use Azure. If you're someone who has a very custom requirement that yes, I want to have an application that can detect, for example, let me show you. Let's say if this is one device which an organization is manufacturing, and we want to train a model that if there is something wrong with the device or not. For example, if the edges are not polished, or if the printing is not proper, or any XYZ reason. So obviously there'll not be a lot of custom models around this. This is a very custom use case. So Azure provides you options of using custom use cases as well. So if you feed 200 images of this device at every different angle, every different lighting, you can create a model in Azure which can tell you that if this device passes the QA or not. If it passes the quality assurance or not. So you could automate a lot of stuff on cloud. You do not need to know artificial intelligence. You do not need to know code. Your life can be easy because there are multiple things to choose from. Either one of the trained models that Azure has, either by training the model without having the skills of coding, so you can just provide your own data, or you could be looking at models where you are entirely managing each and every bit of it. This is going to come in the next slides. In fact, we have this in this current slide as well. So when you talk about Azure machine learning, the first feature is automated machine learning. Now, in this feature, non-experts can create effective machine learning model from data. So let's say uh, we have data of, let's say, and this is a very custom use case. Let's say we manufactured this device. Now, when we manufacture this device, we can have, 100, 200,000, 10,000 pictures at different angles, different lighting. And we can tell it, okay, this is what is good. And let's say if it is scratched out, this is bad. Or let's say if it is torn out, it is bad. If the proportion, if the, length to breadth proportion is not the same, it is not bad. If the curves are not looking like this is bad. If the polish is not like this is bad. So you could have so many data points that you could configure that this is good and this is bad. The more data you feed into your AI model, the more mature it gets. Now when after you're done with the training, you pass it a new image, it'll tell you, okay, from my analysis I can tell you if this is right or if this is wrong. That is a very easy, very simple use case which a lot of people are using. We do not need to have coding skills. All we need to do is we need to have some data. We need to train our model with that, and then we need to test it out. Now, this is one practical which we will be doing tomorrow uh, when we talk about the service in detail. But this is first feature of the machine learning suite of services that we have. So automated machine learning, where you just given the data or you use a pre-trained model and it gives you some analysis. The second is machine learning designer. This is a graphical interface enabled no code development of machine learning solutions. So here you have slightly more customization, like, this is what I want to be monitored. This is how the workflow will happen. If this is detected, please put it in this folder. If this is detected, put it in this folder. A very good example of this will be, let's say you're creating an email application which receives emails. You're working with an email server and developing a custom email solution. You could write code like, if so and so data is present in the email, put this in the spam box. If so and so data is present in the email, put it in important box. If so and so data is available, put it in the regular inbox. So let's say this is inbox, this is priority. So let's say if this is your specific use case, you could be using the machine learning designer where you do not need to have code. It's more of like a drag and drop thing where you just go, you're like, okay, this is what I want to happen. If this is the data that you get, this is what needs to go. So you can train it with maybe 100,000 emails, telling it this looks like spam, this looks like regular inbox, this looks like important. For example, with time, it will be able to understand that, okay, if something is too good to be true, let's put that in spam. If something seems normal, put that in inbox. If something contains words like urgent, to be done, to do, or something of that sort, put that in priority. If something involves money, put that in priority. If something is from Facebook, LinkedIn, Instagram, put that in social. If something is from, let's say, from your bank, put that in the finance folder. So you could have that sort of segmentation, and you could design your own solutions by using the machine learning designer. Now, for the exam, what you need to know is you do not need to know the entire drawing that I showed. All you need to know is there are 4 features of machine learning in Azure. The first one is automated, where you do not need to have any skills. You just need to provide your data and it will do the machine learning for you. Here, I have one thing to explain because it's a thing that is asked in the exam quite frequently. If you, since it's your responsibility to provide the data, if you're creating a custom model where you're giving in the data, and if the data is not accurate and the model becomes, somewhat unfair, if it becomes discriminate, if it does discrimination, if it is not working highly accurately, that is your responsibility. Because for a model to work the way you want it to work, it is very important to provide with sufficient high quality data, which is classified. So you need to classify it, that this is what, this is what a dog looks like, this is what a cat looks like, this is what an elephant looks like. And if you have different angles, different breeds, different categories, your machine learning service will be able to identify that, okay, this person has given me this image, this resembles to what they trained me for. So if you do not give it good training, you cannot have good results. So you could not be blaming Azure for that. So whenever you're using the machine learning service, always remember the data needs to be vast, the data needs to be high resolution, the data needs to be of good quality. and the data needs to be diverse. The the more data you supply it with, the more confident it gets with time. For example, I think back in 2017, I was working at a startup back in India. Not exactly a startup, it was a Canadian company. And what we did for them was we integrated the attendance system with a Raspberry Pi. So what happened was every time the employees used to walk in the morning, we used to recognize their faces and the attendance used to get marked automatically. So there was no punch in and punch out required. There was not tap required, and automatically the door used to open for them. So there was no need for them to, put in the biometrics. So we bypassed that system. That was a proof of concept because we had two doors. So the first door was only for the people with the access card. So we were preventing tailgating that way, but we wanted to avoid the second door altogether. We wanted people to look at the camera, get themselves identified, and the door used to open for them. So when we started working on this, we missed one factor. And I'm talking from my own experience. I was, it's about, I think, 6 years old now, 6 years old story. So things change with time, people learn with time. And since that was a very, very initial stage project, we forgot to consider that there are some facial features that change with time. For example, people might wear makeup, people might start, having different hairstyles, people might start having different, facial hair like beard, or they might style themselves differently, right? And then it gets very difficult for uh, an automated solution to detect what is happening behind the door. So then when we started with this, we started to feel that the model was becoming kind of biased. So for example, it was not able to do proper analysis, it was not able to give us the results that we wanted. And then we realized the main problem with the model was that we did not have sufficient data. So to bypass the project, to process it was, so it was someone else's job to enter the data. What they did was, if they could not, because people were becoming impatient, right? If you are working with, let's say, 100 people in a building which are working on a POC, not everyone will have the time and the energy to work with you, right? When they are giving in the data, they might just have the same face. They might be using they might not be using variety of expressions. So when something of that sort happens, things become very difficult. Because technically, when we looked at our data had, like, for example, if I have to give in my data, if there were 10 images, they were like the same blank expression. I mean, nothing can happen. If you train the model with 10 similar images and I'm walking into the office smiling, the model will be like, okay, I cannot recognize because I do not have the data of the person smiling. If I'm sad, the model will not be able to recognize me. If I have a different hairstyle, the model does not recognize me. If I have a different hair color, the model definitely does not recognize me. If I'm wearing glasses, it does not recognize me. So that is what used to happen. And that's, as I said about artificial intelligence, you need to provide it vast variety of data and it improves over time. So I cannot, let's say if I have a face recognition model, a custom model that we build, I cannot feed it with the information on one day. It is a always evolving process. So we might want to, give in some new data every 3 days, every 5 days, every month, every 2 months, every 3 months, depending upon how accurate that is. And then it will do analysis and it'll give you the result. Now, previously with the Raspberry Pi, another problem we faced was we were using a 5 megapixel camera, which obviously does not do the job from a distance. And then the lighting conditions were not accurate. With time, these things have evolved. The hardware quality has improved. So, you cannot be blaming a machine learning model for the data that you're not providing. So data is a very, very important, very, very important factor which decides what kind of results are going to come out from the solution that you're building. So it's always your responsibility in any of the four models that you choose to, given the correct data, given the correct lighting conditions, give it the, give it all sorts of diversity so that it can perform better, it can do the analysis better. Now, moving on, there is the third feature, that is data and compute management. So using this, the capability is that cloud, for people who know how to write stuff, for people who have been writing their own models on Python, on any other programming language, they could be leveraging the cloud for running those models. Now, I'm not so sure how many of you have used this in the past, but just to give you an idea, when we are training a model for images, we're not talking about 4, 5, 6, 7 images. We're talking about hundreds and thousands of images. And when we are trying to train a model, the devices can easily throttle up. For example, if I have my machine, which is 16 GB RAM, which has got, let's say a 16 CPU, 16 core CPU, it is performing, at 15-20% of its peak performance regularly. But when we go and train the model, we might see that the CPU is overheating. We might see that we need a lot of workloads. So there are two steps in machine learning. One is training, and second is using the model. So when you're performing the training phase, at that time you might require a lot of compute resources, a lot of compute resources, because a lot of processing is happening. Once that is done, things become little easy. You do not require that kind of processing. That's why cloud is a very, very favorable choice for training your machine learning models. Because when you need that extra compute, for example, you want to create a model with 100,000 pictures. If you try to process those 100,000 pictures on your laptop might take, maybe 4, 5, 6 hours to do that. But if you do the same thing on the cloud, you have on demand IT resources, right? You have on demand compute resource. You could be expanding that resource for training, and then you could be reducing that for the recognition of for the day-to-day usage of the model. So uh, that is another feature of machine learning. You could, use your own data and compute management. So you have total control. You're not relying on the cloud. And then the third one is pipeline. So if you have people who work on parts of it, so someone who is taking care of the data, someone who's taking care of the application, someone who's taking care of the deployments, you can be using the pipeline model, and you could be giving roles that, okay, when we are performing this machine learning, this part, data ingestion is going to be handled by, let me get a few new names. Let's say Uday. Data training is going to be handled by Suhas, and then the actual model is going to be handled by, let's say, Steve. So depending upon what your flow in the organization is, how you've implemented machine learning, you could be using either of the four of them. Okay, the model I'm training in background requires 200 hours on local resources. Definitely, Jatin, that is something which I have seen. So when I was working with, the facial recognition model back in 2017, and we wanted to train the data on Raspberry Pi. So we did two phases of it. The first POC was on Raspberry Pi, which, if you guys know, at that time was limited to just 1 GB RAM. It took us, and I'm not joking, it took us 9 hours for that Raspberry Pi to train the data. By mistake, because it's a system on chip, you could touch the hardware. By mistake, my hand went just close to the processor. I burnt my hand. It went so hot, and it was not able to perform the results that we were expecting. I know 1 GB RAM is less, but we had tried to make it as efficient as possible. We tried to keep the data, just limited to the people's face rather than the entire image. We tried to reduce a lot of noise, but we could not get the results. Then we moved to Azure, where we started using the Azure Face API. So we did the data training on Azure, but we did the implementation on Raspberry Pi. Because obviously cloud, as you know, it's not your computer, it is somewhere else. So the ultimate goal, whenever you're using a model, you might have to do, if it is something to do with facial, if it's something to do with video, if it is something to do with something physical interaction, the machine learning services work very well with the IoT services as well. So you could perform the workload check. You could do the, like your device is just going to capture the image and send the data to the cloud. The cloud is going to do the analysis, and it's going to tell you, okay, who this person is. So you could transfer the load of computation, you could transfer the load of training to the cloud workloads, which is going to make your life a little easy. Yes, Jatin. So I worked with OpenCV as well on Python. It was not the best. It was very, very slow. And then eventually I planned to move the workload to Azure, because that way we could have a very small device and we could have more operational expense, so that the processing was done on cloud rather than buying those, heavy machines and putting them at the gate. That would have looked really weird. Okay. Now, since we've discussed quite a few things about this, the next few slides might be going a little fast. Starting with computer vision is an area of artificial intelligence that deals with visual processing. The Seeing AI app is an example of it. Now, this is a very popular app for people, who are visually impaired. Uh, Seeing AI is a Microsoft application which will literally speak out anything and everything it sees. For example, if I install the app on my phone and I just move around with it, it will tell me you have a laptop in front of you, you have a camera in front of you, you have a light in front of you. I see, let's say, someone in front of you. So let's say if I have let's say I have a friend called Sam, and then this Seeing AI app knows that this is Sam because I've already added that information in the app. It'll tell me, hey, Sam is around. Sam is wearing so and so clothes. This is what the person is doing. So you could interact with it, and this is a very very good initiative. It's a very very great. I would say this is practical working. This is one very good use case of using the computer vision, because here you're making uh, you're making something which is having a real impact on the world. For example, let's say if I cannot read some small text, for example, I have kept a few props for today. So let's say this is some marketing material that I received in my apartment, and the text is way too small. So I might not be able to read it without glasses, right? So if I have this application, I'll just point it towards it and it'll start reading things for me. So that makes things very, very easy. So, uh, this is one of the implementation of computer vision. Another one could be Tesla. Another one could be face recognition. Another one could be Face ID. So, you show your face and the phone unlocks. So it is basically capturing your face, right? So that is computer vision. Something apart from this would be self-driving cars, as I've already talked about. So some identification going in the background and then deciding what's an object, if, if something is moving, if something is on a still, and then making decisions based on it. So the decision making part is different, but looking at the getting the input from a camera is what computer vision does for you. Now this could be in form of frames, this could be in form of pictures, this could be in form of a video, and it does not involve audio or any other analysis. So whenever we talk about computer vision, we are referring to what our camera is able to see and it is able to detect. Now, a very good example of this will be filters. If you have used any social media application where you have filters, so it's automatically going to recognize your face and it's going to, apply some filters around it. So that is again computer vision, because the computer is able to analyze, okay, this is the face. So if I have to have a filter of eyeglasses, this is where the eye starts. This is where the second eye starts. This is where the eye ends. This is where the second eye ends. And then they can plot things around that, right? So that is computer vision. I've given a few examples of this already. Google Lens, again, as Jatin, you said in the chat, is computer vision as well. There's another thing that has come up these days. I don't know. I'm getting a lot of advertisements around it. Ray-Ban has got some shades which have some camera in them, and then it is able to detect a lot of stuff for you and give you information and that sort of stuff. So that is again computer vision. Now, when we talk about computer vision, this is the first topic for your exam, which is important, because I remember a few of you asking me how important a certain topic. So this is definitely an important topic. Though I'll just revise this once again tomorrow by telling you what are the important topics. One thing this just crossed my mind. I'm not sure if I told this before or not. The exams are always changing. So the sample questions that I gave you last time for AZ-900 are based on the latest documentation. What I'm going to give you this time for AI-900 is going to be based upon the latest documentation. If you refer to any website for previous questions asked or sample questions asked, the content might have changed. I did get this query for AZ-900 that some people were saying that, there was a question on Microsoft support. What is the support plan? In one of the dumps that, people could find on the internet, but that is no longer a part of the certification. So as long as you're covering all the slides that I share with you, you are having the latest content. You do not need to go beyond. So just read this, understand it. For example, if you look at the slide and you're not able to understand what is image classification, by all means refer the Microsoft documentation to understand what is image classification, but you do not need to go beyond that. Okay, so all the topics are covered. This is all up to date as of today. So you can refer to this for the latest content and do not need to go beyond. If you look at another source which has questions which we have not covered, it is because that thing might have been removed. So you can go and tally that with the latest version of the exam. So as of today, this is what is the latest. And as I'm saying, with time, the content changes for these certifications. I hope everyone's good on that. Okay, so for the first topic for the computer vision models that you need to know for the certification is image classification. So image classification is, for example, you show your AI model an image and it tells you what this is. So for example, if I show a forest and within a forest we have a giraffe, our model has been trained in a way it will tell you that, okay, we have a giraffe in the image. So that is classifying. And then the second image which we show will be of an elephant, will tell you, oh, this is elephant. So it is doing the classification, giraffe hair, elephant hair, lion hair. And this is a practical which is there for tomorrow. We will talk, I'll show you this, how this works in practical. Second is object detection. You pass in an image in computer vision. By whenever I'm saying the term image, it could be image slash video. So please automatically adjust to that. So whenever we pass in an image or a video for object detection, it's going to tell you, hey, in this image that you passed, I could see a car. I could see, I could see a human. I could see ice cream. I could see, let's say, a bus. I could see a sign and whatnot. So that is object detection. So you have objects, it's going to detect them for you. The next is semantic segmentation. So this is basically uh, one very good use case of semantic segmentation. You see, I'm using zoom, right? And I'm using blur. Please observe that everything behind me is blur apart from my body. My face, my shoulders, my hands, you can see them, but everything behind is blur. For example, even if I pick up a device, let's say I pick up a device, it might not be blurred now, but let's say if it's not in my hand, if it was kept somewhere else now, okay, this is again connected to me, but then you see it goes blur. The reason it's going blur is because there is some computer vision that is going on in Zoom right now, which is analyzing, okay, out of this entire frame that I am getting, where is the human situated? Does that make sense to all of you? So when we look at semantic segmentation, I'm going to talk about the theoretical explanation that you need for the certification, but I hope this makes sense to all of you. So please give me a thumbs up if you understand this. Semantic segmentation is the computer dividing the image in terms of pixels, it being able to understand, okay, everything I see from here to here is part of one body. So when the computer is able to recognize that the entire thing is one, it is able to, do it on a pixel by pixel basis. You can see the pixel extremely right to me, just the next pixel is blur because it has done some sort of, it has done some sort of segmentation. It has segmented the entire image, and whatever it feels is a part of one. It is unblurring that. Obviously, it's not 100% accurate. If you see, if I move left and right, some content in my background gets blur and unblur. But let's say if I have the perfect lighting condition, if I improve my lighting, and if I have a higher definition camera, it will automatically be able to detect my face apart from what is the background. So foreground from the background. Whenever you have a foreground and a background thing, you are looking at semantic segmentation. Does this make sense? Give me a thumbs up. Okay. Image analysis, you send the image, it does the analysis, what it is able to find in the image. Face detection, analysis, and recognition is detection is, hey, out of this family picture, I can see first face, second face, third face. Analysis is, oh, I see this person is happy. I see this person is sad. I see this person is curious. So, doing some mood analysis is what is the part of the analysis part. And then recognition. I've seen 100 pictures of this guy. I think this guy is Javesh. Now, if you have some phones, in certain phones, at least this happens in my phone, there is a feature where if I go into my gallery, I can search by people. So there's an option of people and places. Obviously, I'm not going to show you some personal data out of my phone where I show you people, but it has some analysis of the faces of my entire phone. So basically, let's say if I have 100 pictures of me, 200 pictures of my friend, 50 pictures of my family, of my brother, my father, my mother, whoever. It is going to do that analysis and it will tell me, okay, this person, if you click on this, I'll get all the pictures of this person. It might not be accurate because right now, since I've opened the service, I can see there are two, it is identifying me as two different people. So first is me with a straight face, and second is me with a slightly tilted face, with a slight smile. So, it's doing it as two people. It's not 100% accurate, but it is doing recognition. So out of all the data it has done the recognition that, hey, this image has you, this image has you, this image has you. This image has your mom, this image has your dad, this image has your friend, blah, 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 whatever. Now, the next is OCR, a very commonly used technology, that is optical character recognition. For example, we might have heard of OMR and OCR, right? OMR, if you have given some exams where you circle using a black or a blue pen, like you have A, B, C, D all the way to Z, and then you have one all the way to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, and then you mark, right? You have those OMR sheets where you're doing that. That is optical mark reader. You provide it to the computer vision module. It is going to recognize, hey, the person is A1234 because they have selected A1234. Does everyone know what is OMR? You might have used it at some point of time where you black out the dots, where you have, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then you do the circling around it. Give me a thumbs up if you've ever seen it or used it in your life. Come on, I want my audience to be interactive, at least on Zoom. I know if this was in person, things might have been very different. But due to the time constraint that we had for the event, it's happening on Zoom. So please be interactive. Okay, so if you have used OMR at some point of time in your life, you would know that you do the markings and then the computer is analyzing it for you. The reason you do the marking is because people do not want to do manual work. People do not want to see who has submitted the exam. They do not want to do everything on their own. That's why they invented the optical mark reader, where people enter the data, they put it in the computer or the OMR device, and it analyzes the data and it gives you, okay, this is, you're referring to so and so person. Now, a more enhanced version of OMR is OCR, optical character recognition, where you are able to do something like handwriting analysis. So, for example, and show this to you. So, for example, if I write this, I know it's not the best writing, but if it is the right OCR, it will be able to analyze text and it will be able to highlight it for me. Uh, a very good use case of this is, we might have seen, I think in the past year in iPhone, we got this update where we could select text out of our images. How many of you have seen that? Give me a thumbs up. Dhruvan, yes, Adobe Scan is an example of, oh, yeah, it is an example of OCR. Okay, I'm quite sure many more than a few of you who just gave me a thumbs up have seen it at some point of time. So if you see in the past year in iPhone, we've got this feature where you click images and you could select the text out of those images. That is basically an implementation of a character recognizer, which is taking in your images and trying to find out text in those images. You could select that, you could copy that, you could paste that text, you could work around with that text. Okay. So these are the four models of computer vision that we'll be discussing. And just see, this is not related. These are not Azure computer vision models. These are just computer vision models. Azure has services for all these models, which we will be discussing further. So the first one is image classification. So image classification is a machine learning technique where an object such as photograph is classified based upon its features. It can be done using classification models that calculate the probability of an object belonging to a particular class based on its features. For example, if I upload a picture of a beach and then I upload a picture of, let's say, a mountain, it will be able to classify if this is a beach or if this is a mountain. That is classification, where you're putting something in one category or the other. Depending upon how you have trained your classification model, you could train your classification model to, suspicious or non-suspicious. For example, uh, I'm not sure how many of you have experienced this or know about it, but multiple high security facilities, for example, airports, are doing a lot of classification of the people where they are trying to find out if someone is suspicious or not by the moves that they make, by the actions that they do, by, the expressions that they have. You can come to know a lot about a person if you try observing their behavior. So if someone is doing something which has previously been proven to be a trait, you could be undergoing some, additional security. You might be going some additional questioning. You might be going some, you know let's see what's there in the chat. Just a sec. Okay, so you might be seeing that, people are classified. So what they're doing is they could have a computer vision, they could have cameras, and they could, analyze that, okay, this person seems non-suspicious, this person seems suspicious. They could have their own measures around it. I'm not going to comment upon that, not going to comment if this is the right thing or not. But this is something which can happen, which might save people, which might trouble people. It might be good, it might be bad, not going into that. But classification is, you classify either this person is happy or this person is sad. You classify if this is suspicious, if this is not suspicious. So wherever you have, this or this or this or this, that's where you use classification. For the certification, you'll have multiple questions where they'll give you an example that, hey, this is what we want to do. What do you think? Is this classification or not? So in that case, if they are trying to put an image in one of the categories, this or this or this, that's where we are looking at classification. Does that make sense to all of you? Wherever we are categorizing stuff, wherever we are, tagging stuff that this is in this category. Okay. The next is object detection. So when we talk about object detection, we are trying to understand what the image has. For example, this a very good use case of this will be using a self-driving car. So you do not know what's going to come in front of you, right? You might have, let's say, a construction code. You might have a slow-moving vehicle. You might have a bicycle. You might have a car. You might have another Tesla in front of another Tesla, and then they can communicate. You can have a human. You could practically have smoke. I mean, I experienced this thing. I think it was October. So it's a very funny incident. I want to share this with you. So I think this was the end of October 2022. I was in New York, and I was taking a cab from my office back to my hotel. And if you've been to New York, you know that in many parts of the city there is smoke coming out of the ground. So on many streets, it's very, very smoky. So I don't know what's the source of the smoke, but then what happened was, the car was on self-drive because we were a little away from the city. We were just trying to come back. So just for the fun of it, I was having a good conversation with the driver, and the driver put the car on, the self-drive mode. So the car was self-driving, and then on one street there was a lot of snow, a lot of smoke coming out of one of the streets. The car, went into a braking, an automatic braking, because it could not detect what was there in front of it, though it has multiple sensors. Now on that day I got scared. It's something which happened to me personally, and from that very day I realized that, I'm not such a huge fan of self-driving, because that made me, that was nothing severe, but that made me come forward. If I had something in my hand, it might have spilled, it might have hit me, because that was something very, very unexpected, though I was wearing a seat belt, so nothing happened. But that day I realized that, you know, maybe AI and ML is not that mature, and it needs to improve more and more with time. Now, for something like a vehicle such as Tesla is not dependent upon one feature. They have multiple sensors. It's not just the cameras, what they see, it's the radar, it's about, the ultrasonic, what goes out, what comes in. I'm not going to go into the technical details, but a lot of additional, uh, inputs are going into the vehicle. It's not just based upon one specific, one specific input parameter. But let's say if we talk about object detection in computer vision, what we are looking forward for is we want to detect different objects, and we want to detect all sorts of objects that we can, as much as we can. We want to detect if there is some smoke coming out. We want to detect if there is, let's say, a gravel road. We want to detect if something is, kept on the road. We want to detect the lines of the road, that, if we can change lane or we can't change lane, if it's a solid line or a dotted line. We want to detect stuff like, you know, the conditions. We want to detect the visibility. And if it is not visible, we want to alert. So things of that sort are, uh, I can say one of the use cases of object detection. So object detection models are used for detecting the object. You do not need to know the details of it. All you need to know is, hey, there is a human in front of me. Hey, there's a car in front of me. Hey, there's a moving vehicle in front of me. There's a stopped vehicle in front of me. There's a construction cone in front of me, and things of that sort. Okay. Any questions around this? Object detection, anyone? Now, for those of you who are coming from AZ-900, I know this seems quite easy, and that's the reason I call it the easiest certification, because it's very self-explanatory. All you have to do is you can go through the slides once, and you'll be good to go for the certification. Okay, moving on, we have semantic segmentation. This is the one that I was talking about, which we're using on Zoom. So semantic segmentation is an advanced machine learning technique in which individual pixel in the image are classified according to the object to which they belong. The object is me, the human, or any other human. Zoom is trained to, blur any other humans. If I had some other human, they would be doing the same. And, hands and face and hair and the upper body, lower body, whatever it is. So it is doing some segmentation. I'm not going into how Zoom is trained, because honestly, I don't know how it is trained. Something not there in the public domain. But what I know is it is following something like semantic segmentation, because the pixel just next to my eye is blur. The pixel next to my hand is blur. The space in between my hand is blur. So it is doing a classification based on a pixel by pixel basis. And that is when we are looking at semantic segmentation. So if in the question it is asking you for a face blur, or if it is asking you something similar, please connect that to semantic segmentation. Now, just before in the morning when I was going through the slides once, I realized that we do not, we cannot visualize this really easily. So I added a link. I do not want you to go through the entire link. I just want you to look at this image. This is what semantic segmentation looks like. So for example, if we have an image, let's say this entire is, a traffic light. This entire thing is a human. This is a car. This is another car, another car, another car, more human, some signboards. So when you're doing a pixel by pixel analysis, for example, this seems to be something like a tram. This is where, you are doing semantic. So you know that from this pixel to this pixel, we have a car. For example, if I am driving on the left side of the road, I do not need to be worried because the car is on the right. So if we are using semantic segmentation, we will know what is the start point and what is the end point, so that we could decide on what is going to be our course of action. Does that make sense? The attendance link for this session, we'll send that after the break. I do not want any distractions as of now, but you'll soon get them. Okay. Coming back, semantic segmentation, we are doing a pixel by pixel analysis, pretty straightforward stuff. Let me come back to sharing my screen. Okay. So whenever you have a pixel by pixel, okay, pixel gets unique ID to measure the distance. Now, basically, that depends upon how you're implementing it. From a very broad level, if we have to look at these models, image classification is when you have, something and you want to classify it in one of the categories. What you want to classify depends upon the code that you write, or the model that you train. Okay. The second one is detection, where you want to detect that what is there in the image, right? There's a human, there's a car, there is the features of the image, what is there in the background. The next one is semantic segmentation, where you're doing an analysis of the pixel. So you're like, this pixel, this pixel, this pixel, this pixel is part of the face. That's why nothing in between is getting blurred, right? Because all, if I look at my boundary, all the way from the top of my hair to my shoulders, the visible part in the video is all the pixels are given the same object. So for example, if I had another face, or let's say if I have my hand on the right, everything in between is blurred because every pixel is given an identity. So if you go with the definition, it is an advanced machine learning in which individual pixel in the image are classified according to the object. Since the classification is done that, okay, this is a hand and this belongs to the human, that's why it is not blur, and whatever is in the back is blur. So you are analyzing stuff at a pixel by pixel basis. For example, I can have 5 people and Zoom will, have all the 5 faces unblur, but everything apart from that is going to be blur. Even if I turn back, you'll see my back is also going to be unblurred, but everything in the back is going to be blurred. So it is not just restricted to one. It is doing some model which is able to identify that, hey, this is a human, and everything within the human is classified individually. It's tied up to me. And that's why that part is not blur. Everything else is blur. Alokik, does that answer your question? Yes, classification is, again, when I look at the sample questions, you'll understand this better. Let's go next to image analysis. So you can create a solution that combines machine learning models with image analysis techniques to extract information from images, including tags that could help you catalog the image, or even descriptive captions that summarize the scene shown in the image. Image analysis is when you give it an image and it gives you some sort of written text around it. Hey, I see an image with one person standing who is eating an ice cream. I see one person standing who's typing on the keyboard. So that is something where you pass in the so I think I'll just come to the chat in a bit. So yeah, so analysis is basically where you pass in some data and you get back the response saying that this is what it is. This is what the tags are. This is what tags would mean. Like, let's say if I pass in this data and stuff is not blurred. So the analysis will be, there's a TV which is black in color. There is the background, the wallpaper, which is white in color. There's a person standing who looks of so and so age approximately. That is the kind of data it will give you. And then it'll give you a summary. A person sitting in a room with a television behind and staring into the camera, something of that sort. I know that's a very weird description, but that's something which you get with analysis. So uh, to answer that, the class, okay, now let me look what's in the chat. So classification is what is the image, what exactly it is, detection is where, and segmentation is exact pixels. That's absolutely right, Jatin. So moving on to face detection. Face detection is that if you have an image, AI can detect that, okay, there is a face, there is another face, there's another face. And then it can do a lot of different things like, let me get my marker. So face detection and analysis uses artificial intelligence algorithms to identify and analyze human faces in images or video. It can be used for security, social media, intelligent monitoring, advertising, missing person, and identity validation. Now I'll tell you a very good use case of this. Now, I'm not sure how often, uh, I don't think it's there in the Montreal airport, but in many airports across the world, you might have seen that people just need to scan the passport and the face is recognized and the door opens, automatic immigration. How many of you have heard of it? Just give me a thumbs up. I just want to be sure of my audience if everyone gets the context. How many of you have heard that in certain countries you can just scan your password, show your passport, show your face, and you'll be automatically good to go? Automatic boarding, automatic immigration, whatever you call it. I think Singapore is using it. Singapore Changi Airport has it. A version of this has been added to the Delhi airport as well, where people can link their a national identity card, which is called as an Aadhaar card in India. So if you have that, you could attach your face, you could use the Aadhaar card, and it's been recently added a few months ago. So now you have an app, you scan your boarding pass, you show your face, and you're good to go. You do not need to wait in a long queue where someone is identifying your face. So face detection is being used. So one use of this will be in a lot of airports where you can reduce the time of the people waiting in a queue. It is also done at many boarding gates. So if a picture of you has been clicked, you just scan it. You do not need to show, because you might know these days when you board an air, not these days, it's always been the case. Whenever you board an aircraft, you need, just before you board, you need to show your identity card. If it's domestic, maybe let's say a driver's license. If it is an international flight, if you need a passport, you'll have to show your passport. You'll have to scan a boarding card, and then you have to show your face. So this happened with me in COVID. Uh, when I traveled to Canada at the peak of COVID and I was wearing a mask, I had to lower down my mask for every flight, because it's a rule to match your face to, your passport, because they do not want someone else to fly on someone else's name. They do not want the person to be on a no-fly list. They do not want, there are so many things that they want. And for that reason, when we look at face detection, a very good use case of face detection is at the airports, where you can now, because people were a little scared to lower down their masks, right, in COVID. Now things have started to get much better, but back in 2020, 2021, things were not so safe. So many airports came with this idea, and they had it previously as well, because they wanted to reduce human intervention. Scan your pass, show your face, you're good to go straight. As simple as that. So that is about face detection. It can be used for a lot of applications, as you can see over here. Next is OCR. We've already discussed about this. So OCR is basically when you have some data and you want to, read the text out of an image. That's the basic working of OCR. Let's look at the points real quick. So optical character recognition is an area of AI where computer vision and natural language processing intersect. So please understand this. I told this to you when I was talking about NLP. NLP is the human interaction, right? So handwriting analysis. It is understanding the character, but there might be different ways. For example, I might write A like this, which looks terrible. I might write A like this. I might write A like this. And I know these seem terrible right now, but good handwriting recognition or good OCR models are able to categorize all of them as A. Now, this is O. For some human, this might be, they might be confused between O and A, because that's not the AI's fault. That is my fault that I'm typing with the mouse. I'm trying to write with the mouse and my handwriting is not turning out to be the way it should. But different humans have different strokes of handwriting, right? Like for me, this might be A. For someone, this might be A. For someone, this might be A. Even for me, when I try to write it each and every time, it's going to be different, because there's a natural element involved. Every time I speak, my pitch might be different, my volume might be different, my words might be different, depending upon a lot of factors. And for that reason, whenever we have a human interaction, we are looking at natural language. So natural language could be humans speaking out something. So for example, if we have some service like, have you heard of the transcript service on Zoom, where I speak and Zoom translates everything into text? How many of you have heard of it or seen it in the past? Thumbs up, raise your hand, whatever. Just want to be the audience to be interactive. Okay, quite a few. So that's nice. Thank you so much for being interactive. Please be active throughout the sessions, because I know this is not in person. I want to know that my audience is listening to me. It's very important. Coming back, so wherever there's a human interaction, wherever I'm speaking something, my pitch is different, and then it is automatically typing that out for me, showing that out for me. That is natural language. So wherever a computer is interacting with a human and the human is not typing, for example, if I have a keyboard, I'm sure this, yeah. But let's say if I type A, the computer knows this is A, because this is not natural language. This is how the keyboard is typed. Every time I press A, computer knows A is coming. It is not natural language. But every time I speak, every time I do some handwriting, that every time I, type some context where it needs to understand data out of me, that's where it is doing some natural language processing. Okay. And OCR is where the computer vision and NLP intersect, because computer vision is going to detect that, oh, this is what looks like a character. And NLP will be like, I know this guy. This guy has a terrible handwriting. This might look like an A. Does that make sense? Give me a thumbs up if it does. Again, this is something important from the exam standpoint of view. You need to know that whenever we are talking about handwriting recognition or OCR, that is where we are talking about natural language processing because natural element, and character recognition or computer vision because computer is reading that out for you. OCR involves training models to recognize individual shapes as letters, numbers, punctuation, or other elements of text. So if I'm writing an OCR model, I will have to give it 100 types of exclamation mark. People can do this, people can do this, people can do this. 100 types of A. This is A, this is A, this is also A, this is also A. So the better you train it, the better it gets. Technically, in technical terms, what I'm drawing over here is the shape, right? We understand it as character because we understand English, but the computer does not understand it. So you have to process, you have to give in data, and it is going to recognize, it is going to tag individual shapes with characters. OCR technology can detect printed or handwritten text in an image and convert it into a text-based data format. This is something which I'd like to quickly show you guys. So what I'm going to do is I'm going to click a picture on my phone. Let me go to my images. Okay. Uh, I think I'll have to remove the blur filter if I want to show this to you, because again, give me a sec. Let me go to my video settings. Let me move this thing to the side because I do not want to show you the background. It's just for low light. Okay, so I've removed the blur effect so that I can show this to you. So you see, I have an image, and within the image, I can select data. The data that I could select is because it is using some optical character recognition. I could do this for my own handwriting. I could do this for some digital images as well. Now, this goes without saying. Obviously, if I'm going to do this for my handwriting, it is not going to present the best results that are possible, right? Because obviously, humans write differently. Whereas if it is printed, the probability of it detecting something and it being accurate is much, much higher. So pretty straightforward stuff. Just showed you a quick practical on that. Moving on, OCR has many uses such as note taking, digitizing forms like medical records or historical documents, and scanning printed or handwritten checks for bank deposit. Now, this is something which is, we might have used, we might not have used. If someone issues a check to you, you could automatically deposit it. You do not need to go to the bank. You could use your application. You could scan the front and back. It is using OCR because it is, it is checking that, hey, is the name matching with the name on your account? Is the amount matching with the amount that you have entered? And only once it matches, you will be allowed to process your check. Otherwise, your check will be like, hey, we're not processing this because, we see that this is not, we're not sure about it. So please take it to the bank. So that is one implementation, real life implementation of OCR. Now, whatever I talked till now was not in context of Azure. This is where the Azure context starts. So when we talk about computer vision services in Azure, there are four major services in Azure, which are related to computer vision. The first one is computer vision itself. It's called computer vision. You can use the service to analyze images and videos and extract description, tags, objects, and text. For example, uh, let's say if you want to pass an image and you want to get a summary of what's there, you want to have a video and get the summary of what's there, use the computer vision API. It will tell you that, hey, in so and so video, there was so and so person speaking. So let's say if it's a celebrity, it will tell you that in so and so video, this celebrity was talking about the topic so and so. And if it is someone like me who's not recognized, or someone who is not a celebrity, and you pass that to computer vision, it'll be like, hey, it was a guy who was talking about this, and the person also talked about this. This is what I can tell about the person. This is what is the approximate age of the person. This is what the person's lighting condition was, or whatever. So when you give in an image or a video and you want some summary out of it, and when you want to know what are the tags, tags are basically the features, right? So for example, if I give this video right now to computer vision, it's going to obviously take a lot of time to process. It's a long video. But if we pass this to computer vision, the reply will be, I feel that the video that you passed was about someone who was talking about AI-900. So that's a kind of expected response you might get from the computer vision. If we click this picture, the response will be, It might talk something about my gender, it might talk something about my hair color, it might talk something about my face, it might talk something about my background and stuff like that. Like what is there in my background, what's there in the foreground. If it sees me like this, if I go back, it might talk about what's written on my clothes and stuff like that. So let's say if I'm wearing eyeglasses, it will be telling me you have eyeglasses. If I have some piercing, or if I have some jewelry on, it will tell me that the person is wearing jewelry. If I have a watch which comes in the picture, it's going to recognize the watch. And don't worry, I'm going to show you a practical on this. So we are going to do a practical on custom vision, which I'm just going to talk about, a detailed practical of custom vision tomorrow, where we'll train our own model. So we are not just dependent upon what's there on the internet. We have our own data, which I've kept, which I'll share with all of you. It's sample data, share at the end of the day. Uh, and then we'll train our own model and then we'll pass it. So we'll train it on based upon the animals. So for example, hey, this is giraffe, this is lion, this is elephant. Now I'm showing you a picture. Tell me what this is. And you could be using your own pictures from the internet. And then we'll see how accurate this is. Obviously, I might just have a couple of pictures for you, but we will try to see how close we can get to this. Uh, Custom vision is computer vision with custom images. Okay. So what happens over here is you train based upon, so here you're not doing the training. Computer vision it is a self-trained model, which Azure has trained over quite a few number of years now. You give it data, it tells you what it can see from that, right? Now, whatever we were discussing prior to this were general concepts of AI. And when we talk about computer vision services in Azure, we are talking about specific services. So if you consume the computer vision service of Azure, you are using a pre-trained model, which is going to give you description, which is going to give you tags, which is going to give you some objects, what it could find. If you're using custom vision, it is going to give you slightly different information, like depending upon how you've trained it. So if you've trained it to recognize an elephant, it's going to recognize an elephant. If you've trained it to recognize a Tesla, it's going to recognize a Tesla. If you've trained it to recognize a Rolex, it's going to recognize a Rolex. Okay. Next is face. Face is when when you want to detect and when you want to recognize, you can use the face service. And then there is another one, that is form recognizer. So if you have some forms and you want to extract information out of them, for example, let's say this seems to be a random piece of paper. Let's say if this was a form and there was a format, name and people enter their name, and then address and people enter their address. You could use that service. You could train it in a way where you pass this form and it will tell you, okay, by looking at this form, I can tell you the name is this, the email is this, the phone is this. So for for areas where we still have some paperwork going on and we want to digitize them, you could be using a form recognizer service. So for some government agencies, for some processes which are not online, and you want to have the data in a central location, you could be using like a form recognizer. A very good example of this could be, for example, let's say if you want to file your taxes, you could do them online, or you could do it in by paper. So when you do it by paper, they need a way to capture the information that you have written over there, right? So when they want to do it, a possible use case could be using something like form recognizer to extract data out of a form and then use it. Now for the certification, you need to know the name of all these four services and what they do individually. I've already talked about them. Uh, Moving on, we have NLP and quite a few things about NLP. Let me see where we are in terms of slide, and then I'll talk to you. Okay, I think we are on slide 15. We've got still 18 minutes before the break. Let me try and show you a quick practical to gain all your attention. You don't need to do this along with me. You can just observe my screen. And this is just in the best interest of time, so that we can visualize on what we are learning. So let me open portal.azure.com. Okay, I am on a different resource. Okay, so there I am inside my Azure resource. I was just playing around with it a few minutes ago before the event. So I'll just show that to you. Let me go into the cognitive services. I know I've not discussed about them till now, but I'm going to show you something about the computer vision. And I'm using Azure for student subscription, which is the free subscription. So no credit card attached. I will be having a new group. Let's call it workshop demo. Oh, sorry. Now, once the workshop demo group is created, let me give name to this resource. Let's call this practical Azure computer vision. Okay, so there's a name restriction. I cannot use underscore here. Okay, that works. The pricing tier could be free 20 calls per minute, 5,000 calls per month, or 10 calls per second. I want to go with free. Obviously, this is a demo, not using it for production, right? So you need to use responsible AI, which I will talk about further. So I've already read it, that's why I'm checking on it. But I would recommend before using any AI or computer vision in production, please read what is responsible AI documentation. That is a part of the exam. That is something which we will discuss. Okay, 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 okay. So I'm just getting a quick resource created. This will allow me to use certain APIs. Okay, perfect. So resource has been deployed. Now you can see, I'm just giving you a quick demo of what Azure can do for us, right? So now please look at this, that we are not creating anything from the scratch. I did not train a model. I'm just consuming a model. It has created some API keys for me because the service that I'm using is an API based service. Again, we'll talk more about in late, in the later part of the workshop. But basically I'm trying to using the cognitive vision computer vision service, using the cognitive services, I'm using the computer vision API to analyze the images. Okay, so I need to have a public facing URL where I can have an image. So I'll have to find something online, an image that I want to scan. I could ideally be doing this with Python code, Java code, or C# code. But right now, I'm just going to use the API console, which is something used for testing, to show you what kind of data can we expect in the response. So, for example, if we go into analyze image, let's say I want to analyze an image. Now, to do this, I'll have to select the region. So let me just go for East US. And this is the name of the host which I want to hit. I'm looking for, some categories, the language that I want, the responses in English, and you need to read through the API documentation on what you want. You need to pass in the subscription key because that's how APIs work. So I'm just going to get mine. So I've copied this. Let's say this is one of the images that I want to use to, I'm going to pass this to Azure, and this is from the this is from the Microsoft's one of the Microsoft images as well, which is publicly available online. So I'm just going to pass this image in the body that, hey, Microsoft, please use your computer vision, analyze this image, give me what you see in the image. So I sent this request, and there you can see the response. It has done some analysis and it's come back with the result saying that it feels that it is a bicycle, and the probability is 0.996. That is 99.6% assurance that there is a bicycle in this image. So that is what we get when we do an analyze image. There's another API which is also part of computer vision, which is describe image. So this is going to give us more details on the description. So I'm going to open the test console. Again, I am avoiding the task of writing some code, right? In a real world scenario, you'll be writing some code. I'm just giving a demo to you on how this works. So I'll have to call in my API key. I'll have to paste it over here. I'm using the same image. I'm going to send the request. Let's see the response that I get. So here you can see it has done the image analysis. It's given back details like person, outdoor, road, riding, street, boy, bicycle, past, bicycling. And then the text is a man and a child riding a bicycle. The confidence is 46.85%. Obviously, with better images, with images that are clear, you can expect better results. But I think this is good for starters. So this is something which you could be doing. I can show you a couple more examples. Let's say detect objects. So here we can detect what we are trying to, what we can see in the image. So let's say, firstly, I'll need to add the image over here. Let me copy the key. Okay, so the response that we got was the first object we get is bicycle helmet. The confidence is 57%. This is the XYWH. So let's say if we have an image, XYWH will tell you this is the XY coordinate, this is the width, this is the height. So you can draw a rectangle around that place, that the bicycle helmet is from this part of the image to this part of the image. And then there is footwear from this part of the image to this part of the image. So, it's simple maths, right? If you can plot X, Y, and the W and H, you can basically draw, you can draw a rectangle around it. That, okay, for example, if I have my face, if it analyzes my face, it'll be like, this is XY, this is the width, and this is the height. So you can understand out of your entire image, this is the area that we're talking about. And in this area, we have the footwear. In this area, we have the person. In this area, we have the bicycle wheel. You can see, so the data that it is doing an analysis for you, we did not train it. So understand this. When we're using the computer vision service, we have multiple services that we could be using as a part of the computer vision API. And this is by far one of the easiest one. That's why I'm giving an example of cognitive. But in a real world example, you have multiple options to choose from. You can train your own models. You can be using stuff like OCR. This is where I want to discuss this with you guys, because this is kind of interesting. If any one of you has a public facing URL of some text which is written online, please share it with me. Let's analyze that. Or let me find something online, because obviously because this is not a part of what I planned for today. But since I felt that, the crowd is not super interactive, this is something which will give you guys an idea so that you can relate to what we are, what we are studying about. So obviously there's no character over here. So OCR is going to fail over here. But let me see. I'm just trying to find something on the internet, something public facing. If any one of you has anything, you could share it in the chat. But otherwise, let me see. Because I'm not using my code, so obviously I cannot upload over here. I need to pass the URL. It's a test cognitive service that I'm doing. If it was my code, I could have, taken a screenshot of my handwriting and then I would have tested it. It would have been the best possible way to detect how badly things can be detected. Okay, let's just see. Let's see if this image can be passed. Perfect. So Okay, so it could not, the OCR could not detect that. So I think too difficult for OCR. Let me take something like this, hoping something from this will be detected. Okay, I think too bad for this. This should be detected. If not, I'm not sure what configuration is going bad. I'll have to check that. Oh, well, it did detect it. So you see, so this was if when I send this image, it says choose and writing size that fits between the lines. So again, unique. This is, remember the fact, we have not trained it against something. We're just using the pre-trained models, and that's why the results might work, might not work, depending upon what we do. So when we use this OCR, it has selected the text. It says choose handwriting size that fits between the lines. The instructor must, it got confused here. So the instructor must be able, so it detected as e-able, which is wrong, but yeah, that's what happens. So this is normal. It's a pre-trained model. It's something out, not out of the ordinary to read it. And then again, something is missed over here. OU, that is U. So it could not recognize Y. Must be able to, must be able to read it. It is not able to recognize RE, and then it's able to recognize it. So basically, I think the line that is coming, the this specific line that is there uh, on the left, choose handwriting size that fits. So on the left alignment, that is causing some issues. But other than that, it was able to recognize the text. Okay. So you can see you have so many APIs. I do not want to go into each one of them. Coming back to our slides, since we have just 5 minutes, so I'll just touch upon a few topics. I won't go in detail. So this is what is OCR. Okay. So as a quick revision, so computer vision is the category of, computer vision is a service where you can use multiple APIs. They have some pre-built APIs, or you could be, creating the ones that you have to, and that will be custom vision. So if you have a custom model, you're looking at a custom vision API. If you're using a pre-trained model, you're using computer vision. Computer vision has multiple sub APIs where you can detect, text, where you can detect information, where you can detect what is happening, how it is happening. For example, someone is riding a bicycle, so that is task, that is tags. You can have descriptions, you can have object, you can have text and all that stuff. You can also have the X, Y, WH coordinates. So from where to where is the face and things like that. Custom vision, a detailed practical on this, we'll all do it tomorrow. So today what I did, I did not expect all of you to do it along with me. Anyways, only 5,000 requests are free. So that was just like more of like a test thing, not a prod thing. And then we have face. Face service is for building and recognizing faces. I wish I would have done this, but in respect of the time that we have, we'll not be covering this. We'll be looking at the service. We'll be understanding about the service, and form recognizer is for forms. And the next topic, I'll just touch upon this in the next 3 minutes that I have, is natural language processing. So NLP is an area of AI that involves creating software that understands written and spoken language. So the things that the key takeaways from the slide will be that NLP is not just spoken, it could be written. NLP can be used for analyze and intercept text, spoken language commands, and translate between languages. So a very common question for the exam will be, if you're using natural language processing, can you translate between languages? So the answer is yes, because for translation, it is very important to get the input, and the input is going to be slightly different, right? The grammar might be different. The way of writing the sentence might be different. So the system needs to understand the context like what the person is trying to say. So when you have that, you are dealing with NLP. We've already discussed this in brief, so I won't spend a lot of time on it. And now we have NLP in Azure. This is a very, very important exam question. There will be quite a few questions on this NLP in Azure. So they'll be talking about, which service does what. So you need to know that there are four services that you need to know for the certification in NLP. First is the language service. Second is a translator service. Third is the speech service. And then the fourth is the Azure bot. The language service, we use this service to access features for understanding and analyzing text, training language models that can understand spoken or text-based commands and build intelligent applications. For translator, you use the service to translate between more than 60 languages that they support on Azure as of now. So we can look at the documentation and see what languages are supported and what aren't. Speech, we use a service to recognize and synthesize speech to translate spoken languages. Please understand this very carefully. You might have seen a lot of videos getting popular in the past few years, a lot of instructional videos on YouTube where there's a human-like voice that is speaking, but it is not human. So that is the NLP service where Azure provides this, AWS provides this. AWS calls it Poly. In Azure, it's called the speech service. So text to speech, it sounds like very, very natural. So you can have things like you can have pause, you can have high pitch, you can have low pitch, you can have, uh, you can set the speed, you can choose one of the speakers, you can have, one of the accents that you want to choose from. So it is not robotic voice. Previously, a few years back from today, when we used to hear robotic voice, it was very monotonous, like something 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 something, which sounded very robotic. But with the speech service, it is very human like. So this service can recognize and it can also synthesize speech, so you can be using it for recognizing speech to text, and text to speech can both work with the speech service. And then we have Azure Bot, which is slightly more complicated. So we'll discuss in detail. In fact, I'll discuss NLP in detail after the break as well. Just wanted to have a quick touch base upon this so that you guys know what is going to come up in uh, the next 2 hours. So now I'll be stopping the recording because I want to keep two recordings per day, 2 hours each. And then I'll continue talking to you